All right. So I was telling my story at Delta where I built this node middleware which would call an endpoint and give personalized content about the user and then pass it on to the web app. This was thoroughly tested before going live, and my chest was swelling up with pride as there was 0 bugs identified. So I was totally confident, and then it went to prod. So this is what happened. A few days after the release, we experienced slowness at delta.com, and I was sweating on the prod call. Turns out that I was calling the endpoint through the firewall from outside the network when I could have just called it without hitting the firewall. The firewall was not prepped to handle such a massive increment in traffic and started experiencing congestion. This and many such experiences have been a constant reminder for me that building apps at scale is a totally different ballgame than building smaller apps. It requires a lot more careful planning and rigor. I've spent close to 2 decades building enterprise applications at scale, and today I'm here to show you how you can do the same. While I have picked up Delta-specific examples, I've carefully chosen them so that this will apply to you as well if you're building an app for millions of users or something that is flexible and scalable and yet robust enough to stand the test of time. So let's get started. These are the things to consider. Number 1, separation of concerns. All these apps on delta.com, they are physically separate. They have their own pipelines. They are deployed to separate servers. Now, we could have built one single page application, easy to build and maintain, right? But at this scale, there is so much going on with these apps. The last thing we want is if there is a problem in specific area, it becomes a site-wide problem. That would not be good. There's so much going on with these sites. There are third-party plugins that could misbehave, copy changes and feature toggles being done by market-specific tests being run by them. Each area could have its own downstream dependencies, and they might be going down or experiencing slowness. And even with the code changes during a release, we might have introduced a bug or performance problem. The last thing we want is, let's say, if the Seats app is down, and then shopping and checkout to be down as well. We don't want that. We want that user would be able to still book their tickets. So this separation of concerns ensures that issues are contained and they don't become a site-wide problem, which would be devastating for us. Also, this makes it easy for support and maintenance because we can give ownership to individual teams, individual apps to individual teams. Now, even for a single page, sometimes you might need this micro front-end architecture where each of these boxes are actually mini apps in itself. They are isolated components. They are built separately and fetched together from separate sources. They might have APIs to communicate with other components on the page. So how to build this? The technical solution to build something like this will depend on your goals. For example, let's say you are actually integrating third-party components which you really don't trust and you need full isolation, then you can use iframes. The downside would be performance, as this is almost like another instance of browser within your page running its own JavaScript and content. So that's iframes, but a more shared way to do this would be custom elements. You can use Angular elements as an example, where it's still a mini app, but the JavaScript resources can still be shared across them. And also, communication is possible through attributes. If you have a page with different versions of Angular or even different technologies, you can use custom elements. If you just want to develop the component separately and make it shareable across apps, you can use library components. these can be developed separately, but are part of the same build if you are after compilation. Last point on this topic, you still want your apps to be load balanced across many servers or many Docker containers, depends on your infrastructure, to make sure that we can handle certain surges in traffic and also provide resiliency just in case the server goes down because of hardware issues or any unforeseen problems. Let's talk about effective content management. Like many sites, we maintain all our labels, descriptions, API responses, success and failure response text, images in a content management system. So business or marketing is able to make changes to the live site without needing a deployment, which is all great. But also, unlike a WordPress site or a traditional CMS where content is strongly glued to the page, it's maintained and built as part of the page, we use a headless CMS. Here, the content is stored as key value pairs in a separate database. The headless CMS gives you a web API, and our Angular app will call that API, get that response JSON, and get the key value pairs from there and map it to content on the page. So why do it this way? Well, this separates out the presentation layer and the layout from the content. We have to support all kinds of devices, from the oldest cell phone in use to the latest tablets or desktops, and so many browsers and resolutions. We cannot let the marketing team change the presentation without doing the rigorous testing that we do during development. So we let them own the copy text and the images, but we own the presentation layer. So to recap, the benefits of CMS: business marketing in full control of copy and images, no deployments necessary to make changes to the live site, and the next two are specific to headless CMS, where developers control the presentation layer. And since your UI is, your content is totally separate from the UI, you can build multiple UIs with the same content. You can build maybe a mobile phone app with the same content. Let's also talk about how this will, we can make this performant. So after changes are made to the CMS system, we actually propagate all those changes to content servers on the edge across the globe. So what are some of the benefits of keeping the content on the edge like that? Content available everywhere and at all times. Let's say your business is in the US, but somewhere someone is accessing it from Australia maybe. So they will get the content from a server closest to them. So remember that on the internet, less hops means faster load time. And to achieve this, these days is very easy. You can use tools like Akamai or Fastly or Netlify. Tools like Akamai also give you additional security, like blocking DDoS attacks, blocking access to certain URLs, or providing effective redirects, things like that. All this content is always cached and on these edge servers, and they are also very good at cache busting. So if we make changes to the CMS, those are propagated to the edge servers pretty fast. This will also give you resiliency, as if any of these servers, edge servers crash, then the user can pull in content from the next server. So with so many content servers available, user is guaranteed to get his content. Next up, let's talk about error tracking and application management. Alan Perlis who is known for his pioneering work in programming languages, had this to say about errors. There are two ways to write error-free programs. Only the third one works. In other words, if you are writing code, be sure to handle all the bugs. Now, there are some quick fixes you can do, but we'll try to do things the right way. So let's start with prevention strategies. As your feature set grows, there's no way you can keep up with manually testing everything. So you do need unit tests, integration tests, and E2E tests to have coverage over all your features. And also, as new features are being developed, the automation team needs to keep up with it and provide coverage for additional features as well. And this is an ongoing effort. And since we have to support so many devices and browsers and resolutions, we can use a tool like Browser Stack that provides an API that we can call to run these tests across different devices and browsers in their own form. We also load test before going live in a simulation just like production, and manage to find issues which could be real big problems in prod. Slow memory leaks is a very good example of that. But regardless of how hard you try, errors are still going to be there. So here are some strategies to effectively manage them. Make sure that you do log as much details about the errors as possible. This will help you later. But do not log things like PI information. On the server side, you can log them to log files. But then you can have a log aggregation tool and querying tool that can aggregate all of that to its own database. Typically, these querying tools will have its own query language that you can use to pull up an error for a very specific date range, matching a very specific error string. So they can be very powerful. You also need to log errors on the client side. Now, why do you need that? Typically, you can open the browser console and see all the errors yourself, right? A lot of times what we see is not what the end user is seeing. A third-party plugin might be changing something on the live side, and a user in a very specific market, in a specific scenario, might be getting an error or a problem, and you don't see it. So that's where tools like Track.js can be used. They log errors for the entire user base across the board. So you can query it to figure out what was wrong with the user without being able to replicate it yourself. Apart from that, you'll also need application monitoring tools. Apart from monitoring CPUs and memories and all that, you will need tools like APM tools like Dynatrace is an example of a very powerful application monitoring tool that will give you system-wide alerts based on errors or failures. It can also alert you if SLAs are not being met, if there is slow response in certain parts of the system. It can also alert you based on some abnormal behavior. It uses AI to figure out those kind of things. For example, let's say there is an API and calls to that API have dramatically reduced all of a sudden. So it can track that as a anomaly and alert that something might be wrong. Let's move on to API orchestration layer, or a BFF layer. So what's a BFF? Not best friends forever, but a backend for frontend. Large-scale UIs typically have to call multiple APIs across different domains. So you can use a BFF layer that can reduce the complexity and integrate with all these downstream APIs. And in the end, it can provide a very much simpler API that the front end can call. To speak through the next 2 points, I want to make a case of moving as much JavaScript code to the BFF because see, the UI is a very insecure layer. You cannot save secrets in the UI. Any validation that you add can easily be bypassed by manipulating the DOM or modifying the JavaScript. Second point, we are not sure how good or bad the end user's device is. He might just be on an old cell phone on a slow network. And if there's a lot of JavaScript to process, he might have issues with that. So it's best to push as much validation and business logic downstream as possible. And BFF could be a good place to do that, because BFF is part of the infrastructure, so it's secure, and you can also give as much processing power as you want. BFF will also ensure that minimal data is passed to the front end. It can aggregate data from multiple APIs, but then it can filter it down and only pass the minimum data that the UI needs to build the presentation layer. GraphQL is a query language that the BFF can employ to achieve some of these goals. Next up, let's talk about feature toggles and incremental rollouts. Where would we use those? So let's go with the first one, safe launch of new features with on-off flags. In a mission-critical app like delta.com, any changes that you make can positively or negatively impact the revenue, something that everyone is watching. And sometimes we are not even sure of a new feature we are launching. So we typically build these features with a toggle switch, and we use that to turn it off and go to the old flow if things don't work out. Also, we can use that for A/B testing. So for a new functionality that we are planning to add, we might come up with more than one UX flows or designs, and we can end up building both of them, but with these toggle switches, so that we can turn them on for different markets and figure out the winner. For very mission-critical features, dramatic changes to the experience, we use a slow rollout. So we'll first roll it out to 1% of the user, and if things are looking good, we are getting positive feedback, then we increase it to 3% of the user, then 5%, 20, and so on. It's only when we are fully confident and it goes 100% that we can take the code out for the old flow. This slow rollout will also help us in learning and iterating. So if there are UX gotchas in whatever we have built or bugs, we can iterate and fix them while working with a smaller user base before we spread it to the entire user base. So in conclusion, if you have a mission-critical app, very important to the business, and a wide user base, these are some tools that you can use. You don't necessarily have to build your own feature toggle or slow rollout tools. There are tools available in the market like Rollout or Launch Darkly that you can use. So to recap, we discussed how separation of concerns is going to make your system more stable. We discussed how what kind of CMS to use, effective error handling, using a BFF, and using feature toggles and incremental rollouts. And that's it. You did it. You now know everything you need to know to build applications at scale. If you have questions about any of this, feel free to reach out now or later. And I do appreciate you spending your time with me on this. Hope this helps. Thanks much.